Welcome to today's Vectorworks Architect SIA Engineer workflow presentation. My name is Dan Monahan, and I'm the Managing Director for Nemetschek SIA. For over 15 years, I've been helping firms evaluate and successfully implement AEC technology. A lot has changed in that time. Today, more and more architects and engineers are being asked to participate in collaborative, model-based workflows. With support for OpenBIM, Nemetschek Vectorworks and Nemetschek SIA are making it easy for firms to plug into these new workflows and to share models with others involved in the design and construction process. In this presentation, we'll use the DC Riverside project as an example project to illustrate the exchange of OpenBIM models based on the IFC file format. IFC, or Industry Foundation class, is supported by all BIM programs and provides a neutral way to exchange BIM model data. In this presentation, we'll focus on the IFC exchanges between the architect and the engineer using Vectorworks Architect and SIA Engineer. As is typical today, the teams in this project all use different BIM authoring tools, i.e., the software that they felt worked best for their part of the design process. To help organize the team, this project used the American Institute of Architects E202-2008 documents and BIM protocol exhibit as a guide to manage the BIM model development and exchange. Similar BIM protocols are available in other countries, for example, the Statsbygg BIM Guide in Norway and the Senate Properties document in Finland. The benefit of these documents is that they clearly define who's responsible for what at the various stages of the model/project progression. The AIA BIM documents introduce the concept of model LODs, or levels of development, for each stage in the design process. These stages somewhat overlap the traditional workflows, but instead of 7 or 8 stages with very unique aspects, there are only 5, which focus on the development and the details of the BIM model and the responsibilities of each of the team members. While the stages appear linear, from general to specific, the BIM Guide really promotes an iterative process where team members are involved early in the design and regularly review and exchange model data. For the purpose of this demonstration, we're going to focus on the LOD 200 and LOD 300 stages of model development. This project started with the architect delivering 2 Vectorworks IFC files, an LOD 200 model of the architect's early concept of the architecture, and an LOD 200 model of the architect's early concept of the building structure. Allowing the structural engineer to reference and reuse the architect's model is a huge improvement over today's traditional workflows. Here, you can see the 2 Vectorworks IFC models together in SIA Engineer. Some people ask, why 2 models? Well, having the architect's model as background geometry helps the engineer better understand the architect's intent and reduces the number of RFIs, or requests for information. Having the structural model means that the engineer doesn't have to start from scratch. Instead of having to import 2D CAD drawings and remodeling the structure as you would in a traditional engineering analysis program, SIA Engineer lets me easily reuse the structural geometry the architect has already created. For example, in this model, floor slabs transfer in as 2D elements and beam as columns as 1D elements. Now, from the architect's model, I can begin to verify and, where necessary, clean up the architect's information. This concept of being able to clean up an architect's model is another important technology in SIA Engineer that makes the model exchange between SIA and Vectorworks useful. As you know, architects and engineers think of structures differently. Architects tend to think in volumes and are typically not concerned with modeling the structure as a real coherent structural model that's needed for analysis. So, how do you go from the architect's model to a proper analytical model? With traditional analysis software, this is either impossible, i.e. I have to remodel the building in my A&D software, or the cleanup is very tedious and time-consuming. SIA Engineer provides a suite of tools that make it easy to convert the architect's model into a proper engineering model that's ready for analysis. Here's a simple example of what I'm talking about. Here, we have a column as it would be designed in Vectorworks Architect. But the engineer needs different information. He needs this schematic representation, the plate, the foundation, the column, the beams, described as bars and nodes. This is classical for an engineer. But how do you go from this to this? This ability to convert architectural objects into proper analytical objects is a key feature in SIA Engineer that makes the model exchange between Vectorworks and SIA useful. In this view, I've set the Vectorworks Architect model to display gray so you can clearly see how it's being used as background or reference geometry. And we're beginning to convert the Vectorworks structural concept into an early stage structural model. So, from the architect's early stage LOD 200 models, the engineer would use rules of thumb and maybe some light analysis to return to the architect an early structural concept model, or what we call the structural LOD 200 model. This model would be returned to the architect for validation before we continue. In this project, as is typical, the architect, owner, and contractor evaluated the design and decided to make some changes based on cost, constructability, and aesthetics. Here, you can see the more refined Vectorworks Architect LOD 300 model and how it's changed from the LOD 200 model. In this project, the tower roof was simplified to a flat structure, and the east wing penthouse was developed into a full floor to maximize the lettable area. So, from the architect's more developed LOD 300 model, we reworked our structural LOD 200 model to incorporate these changes. The result is a more developed LOD 300 model of the structure that's now ready for loading. Here, you can see the live loads being applied to the floors in SIA Engineer. Next, we set up the model for wind loads, and we would continue to add loads and load combinations as necessary. Then, with the loads defined, we're ready to move on to analysis and design. Here, we're looking at a fundamental mode in the x-axis. And here, we can visualize the central core deflecting under some seismic excitation. The central tower portion of this project required some special attention, as the tower housed the building's mechanical systems and service core, as well as a 6-story open atrium that was an important architectural design element. From the Vectorworks IFC file, we were able to easily derive an accurate analytical model, make refinements, and then pass back to the architect an updated model of the tower structure. Here, you can see the bending moments on the tower atrium steel frame, and we could see the results graphically on the physical model of the structure. This ability to integrate the physical and the structural model in SIA Engineer means that we can visualize instantly how changes like editing a cross-section, adding bracing, or moving a member will affect the shared structural model. This was important in this project as the tolerances for the mechanical systems were pretty tight. Here, you can see the shear on the tower core walls, and using these values, we could optimize the tower core's reinforcement. And because all structures are tied to the ground, it's important to consider the effect design decisions have on the soil structure interface. Here you can see the bearing stresses on the soil. If needed, we could design piles or other foundation supports and then feed that information back to the architect. Once we're finished with design, we could then begin to document the project. Here you can see the framing plans that were automatically generated from SIA Engineer's structural model. Also, because we've maintained the Vectorworks Architects model in the background, we can give a much more complete representation of the structural system within its actual context. The Vectorworks model is being displayed gray in these drawings. And here are some section drawings generated from the SIA model. Of course, these drawings are linked to the model, so they'll automatically update as the design changes. And these drawings can be exported to Vectorworks Architect as DXF DWG drawings or shared as PDF files. Being able to share and merge the architectural and engineering models allows new ways to communicate our design. Here we have a 3D PDF of the DC Riverside project. Using 3D PDF, we can create a 3D presentation that anyone can navigate and examine. Using the navigation tools available in the free version of Adobe Acrobat Reader, a reviewer can zoom in and take a closer look at the models. They can change their rendering settings and look inside and see the architectural and structural models working together. And they can even fly around or walk through the design to get just the look that they need. Again, this presentation didn't require any special software or even any extra work. It comes as a side benefit of having the models and using open standards like 3D PDF. In this project, the architect's original design called for tall, brace-free glass curtain walls in the atrium lobby. These large unbraced column lengths required very large and expensive built-up cross-sections, After further review of the LOD 300 structural model, the architect decided that the cost of these large built-up columns wasn't worth the aesthetic effect. So we conferred and jointly decided that we could change them to steel. In this slide, the architect is notating in the Vectorworks architect model the location for the bracing. And here you can see the updated model in SCIA Engineer. Next, we reran the analysis, finalized the structural design, and then sent our changes back to the architect for his approval. And during this process, we were able to track and store changes. In this case, SCIA created a project archive of all the iterations of this design. Using this same iterative workflow, the model was further refined until the design was complete. Here you can see a final rendering of the architecture rendered in Vectorworks Architect. Here are IFC models of the structure and the mechanical systems working together. And lastly, here's all three together in the finished design. Well, that concludes today's presentation. I hope I was able to illustrate some of the benefits that OpenBIM offers, and specifically how using IFC can create a more integrated architecture engineering workflow for Vectorworks and SCIA Engineer users. For more information on the DC Riverside project, and to download the Vectorworks Architect, SCIA Engineer, and IFC files, this project has been archived on the BIM in Practice page located on the Vectorworks homepage. That's www.vectorworks.net BIM in Practice page. For more information on OpenBIM or specific questions about Vectorworks Architect and SCIA Engineer interoperability, please contact your local Vectorworks or SCIA reseller. Or feel free to email me directly at dmonahan@scia-online.com. And keep an eye on your inbox for invitations to more OpenBIM presentations from Nemetschek. Thanks and have a great day.